Hi guys, in this video we are going to be looking at the sigma notation. Sigma is represented by this fancy E over here. That is what we use to represent sigma. But then before we go deep into sigma, it is important that you understand how to do arithmetic series and geometric series. You have to know how to find the arithmetic sum, and you must also know how to find the geometric sum. Okay, so when we are looking for the sum of a geometric sequence, this is the formula that we use. Sn is equal to n over 2 into 2a plus n minus 1d, or you can use this one. Sn is equal to n over 2 into a plus l. So this one, the second one, we use it when we are given the last term of the series. And again, in order for you to be able to use a formula, you must know what each variable on the formula stands for. Okay, so here we have Sn. Sn is the arithmetic sum. N is the number of terms in the series. A, we already know, is the first term of the series. D is the constant difference, and L is the last term of the series. So if you know what all these variables are and you know how to find them, then you will be able to use the formula. Similar with a geometric series, we also have a formula. Sn is equal to a into 1 minus r to the power of n, all divided by 1 minus r. Again, you must know what the variables stand for. You have Sn, it's the sum. You have a, the first term, r, the constant ratio, and n, the number of terms in the series. So if you understand these two formulas, the formula for the arithmetic series and the formula for the geometric series, then you are not going to have problems when it comes to sigma. Okay, let's now look at sigma. So sigma, I have already explained that it is represented by that fancy E over there. So usually what you will find is that the E will have a number at the bottom, and then it will have a number at the top, and there will also be an expression on the right hand side of the E. So that number at the bottom of the E is where you start evaluating your sigma, and the number at the top is where you end. And then this expression here that you find here is, it will normally be the general formula of the sequence or the series that you are supposed to evaluate. And this whole thing over here, this whole thing, it simply means sum. Remember, when I was showing you the formulas for series, they were like Sn is equal to something. So this sigma over here, this is the sum, and the sum is Sn. Okay, so in our formulas there was an n there, and I explained that n is the number of terms. So that number of terms, this is how we find it. We say number of terms is equal to m. M is the number on top, minus n. N is the number at the bottom, and then plus 1. This expression here will give you the number of terms that need to be evaluated in the sigma notation. I hope it's clear. But then to check if everything is clear, let's try to do an example here. So in this example, they gave us sigma notation, and the instruction says evaluate. So a lot of learners, when they get here, they get confused. They don't know what to do. So when they give you sigma and they say evaluate, what they are simply saying to you is that what is the sum of these? Remember, sigma means sum. They just want to know what this is equal to. Okay, so step number 1, look at this formula, the formula that you have here. Check whether it is geometric or arithmetic. And the reason you have to check it is so that you will be able to pick the formula that you're supposed to use to evaluate the sum. Okay, so in this example, our formula is 2n plus 1. And by looking at it, it is an arithmetic sequence. It is the formula for an arithmetic sequence, right? Therefore, if we are looking for the sum of this sigma here, we're going to use the formula for an arithmetic series. So we're going to say Sn is equal to n over 2 into 2a plus n minus 1d. So we have identified the formula that we are supposed to use, right? So now we have to find n, we have to find a, and then we have to find d as well. Okay, so let's start with n. Our n is going to be, remember, n is the number of terms. So in order for you to find n, you are going to say the number on top. In this case, it's 6. So we're going to say 6 minus the number at the bottom. The number at the bottom in this case is 1, and then you're going to say plus 1, and then it is going to give you what? It is going to give you 6. So our n in this case is 6. Okay, then let's move on to finding a. So in finding a, from the sigma notation, we are told that we have to start at 1. So our a is going to be at the point where n is equal to 1. So we're going to say 2 into 1 plus 1 is equal to 2 times 1 is 2 plus 1. It is going to give us 3. So this is our a. Okay, let me put them here. So our n is 6, and then our a is 2. So we have found a. So now that we have found a, what is left is d. And then how do we find d? D, we're going to say term number 2 minus term number 1. So it means we must also find term number 2. Our term number 2 is going to be where n is equal to 2, right? So let's say 2 into 2 plus 1, that is going to be equal to, okay, 2 times 2 is 4, plus 1 it is 5. And then when we say 5 minus 3, we want to find d. So we're going to say t2 minus t1. 5 minus 3, it is going to give us what? 2. So which means our d is also equal to 2. So now we have all our variables. And since we have all our variables, we can come and substitute. So we're going to come and say Sn is equal to, okay, we're going to say therefore Sn is equal to, our n is 6 over 2 into 2. Our a is 2 plus n minus 1. Oh, our n is, apologies for that, our n is 6. So there we put 6, and then our d is 2. Then we put it there, and then you punch that on your calculator. It is going to give you 42, and this is the sum of your sigma. So you can just come here and say this is equal to 42, and that is how you evaluate sigma notation.